This is a homework video for section 9.6. You were assigned problems on page 559, 4 through 10, 22 through 28 evens. That's 8 problems. I'm going to do half of them, so I'll do problems 6, 10, 24, and 28. So let's start with number 6. For number 6, we're asked to factor the trinomial. So this is an expression, it's not an equation, so we don't have to solve this to completion. We just have to factor it, and once it's done factoring, we are finished. So when we factor a trinomial, the first thing we start with is a pair of parentheses. Why a pair of parentheses? Well, because more than likely, this trinomial is a product of a binomial multiplication. So a binomial times a binomial usually leads to a trinomial like this, so that's why we set up the parentheses. And then we take a look at our first term, the s squared, and we think to ourselves, well, what times what more than likely gives us an s squared? Well, more than likely it's s times s. So I write an s here and an s here to satisfy my FOIL first term, because if you were to FOIL multiply this, the f would be for the first. S times s gives us the s squared. Then I take a look at my next two numbers, the 10 and the 16, actually the negative 10 and the 16, and I'm going to find two numbers that add up to a negative 10, yet they multiply to come up with a product of 16. The easiest way to do this is to look at the second number, the product of the multiplication, and figure out what terms can get you a 16. So you can go with a 4 and a 4, so 4 times 4 is 16, but can you get a 10 out of a 4 and a 4? No, there's no way you can do that. Okay, what about 8 times 2? 8 times 2 is 16. Can you get a 10 out of an 8 and a 2? Sure, you can. You have to combine them. In the case of a negative 10, they both have to be negative. Both the 8 and the 2 have to be negative. So you write negative 8 minus 2. That'll give you a negative 10. And then if you take negative 8 and you multiply it by negative 2, that'll yield a positive 16. So those should be my numbers. And you're essentially finished. To double check your work, you can just simply FOIL this out again, and you should get this as the answer, but that right there is our finished factored answer. So next I'm going to do number 10. So the number 10 is n squared minus 9n plus 14, pretty similar to what number 6 was, and just like before, you start with a pair of parentheses. And then you look at your first term. In this case, the first term is an n squared. And you figure out what two numbers, when multiplied against each other, will yield an n squared. More than likely, it's n times n. I say more than likely because you could technically get half 1 times n squared, but we're not going to worry about that right now. We're going to take the easiest route. So I'm going to write in an n here in the first term and an n here in the first term to satisfy my FOIL first. Then I want to take a look at the two numbers that come afterwards, the negative 9 and the positive 14. So negative 9 and positive 14. And then I want to try to find two numbers that will add up to negative 9, yet they will multiply up to positive 14. So to make that easier, I'm going to look at my multiplicative product, the 14, and figure out what two terms can multiply to give me a 14. 2 times 7, can I get a 9 out of a 2 and a 7? Sure I can, but since it's a negative 9, both the 2 and the 7 have to be negative, so negative 2 minus 7 will add up to that, and negative 2 times a negative 7 will multiply to that. So those should be my two numbers. The order doesn't really matter. And that's it. That was pretty easy. That's my factored form of the trinomial. So I'm going to move on now to number 24. So number 24 is pretty similar to number 6 and 10, except now it's no longer an expression, it's an equation. See, it's got an equal sign, it equals to something. So they're asking us to not only factor this, but to actually solve it to completion. And this is how this problem goes. You started up just like number 6 and 10. You factor it out first, because if you were to solve this problem as is and you try to isolate w, you wouldn't come up with an actual answer. You would always have a variable in your answer. So let's go ahead and put up our two parentheses, because that's what we do when we factor a trinomial. And then what two numbers, we'll look at the first term, the w squared, and what two terms can multiply to give us a w squared. More than likely it's going to be a w times a w. Alright, perfect. So we got our first term out. And then we're going to take a look at it still equals to a 0. Can't forget that. It's no longer an expression, it's an equation now. Then we're going to go ahead and take a look at our next two numbers. I'm going to write them to the side here, the negative 15 and the positive 44. What's going to add up to negative 15 yet multiply to positive 44? I'm going to again look at the second number and figure out what are my two multiplicatives that can multiply to 44. 2 times 22, that'll work. Can you get a 15 out of a 2 and a 22? No, not really. 4 times 11, that'll work, because I can get a 15 out of 4 and an 11 if I combine them. And since it's a negative 15, both the 4 and the 11 have to be negative. Negative 4 minus 11 is negative 15. Negative 4 times negative 11 is positive 44. That works. Perfect. But now, since this is an equation, we actually have to solve this. But thankfully, we know how to do this. This is the zero product property rule. We had problems like this in section 9.5. Since w minus 4 times w minus 11 equals to 0, either the w minus 4 or the w minus 11 has to be 0 by themselves. So you set each of the binomials equal to a 0, and then you solve for w. So in the first case, if you add 4 to both sides, w equals to 4. In the second case, if you add 11 to both sides, w equals to 11. So those are your two solutions that will make the statement true. So if you plug in either a 4 in here, or you plug in an 11 in here for the w, it'll make the entire expression equal to a 0. I'm not going to check my work, but you're more than welcome to. It should come out to the right answer. So I'm going to do the last problem now, which is 28. So 28 is pretty similar to number 24. It's an equation, except it's not equal to 0, and we have that 7 on that right side of the equation, which looks kind of weird. So what we can do is we're going to move that 7 from the right side to the left side by essentially subtracting 7 from both sides. Because I want this equal to a 0, because this will allow me to use my zero product property down the road. So I'm going to get y squared minus 2y, and then it's going to be minus 15, all equals to a 0. Good. Now this looks like just like the problem in 24. So I want to factor first. I'm going to come up with my two parentheses. I'm going to look at my first term, and I have a y squared. And what two terms can give me a y squared when multiplied? Well, a y times a y. So that's for my first term. And then I'll look at my two numbers. Sorry, that's still all equals to 0. I'm going to look at my two numbers that come next, the negative 2 and the negative 8. Negative 2 and the negative 15. Don't look there, look here. So, because this is our modified equation now. So negative 2 and negative 15. So I want to find two numbers that add up to a negative 2 and multiply to a negative 15. Alright, so let's look at the negative 15 and see what multiplies to a 15. 3 times 5 comes to mind. Good. Since it's a negative 15, either the 3 or the 5 has to be negative. And what adds up to a negative 2? Well, I can get a negative 2 out of a 3 and a 5, but the 5 has to be negative and the 3 has to be positive. So 5 minus 3, for this it works, and 5 times negative 3 works for that. Perfect. So the 5 has to be positive, the 3 has to be negative. The order in which they go doesn't really matter. So I factored it out. So all that's left now is to apply my zero product property and set both the y plus 5 equal to 0 and the y minus 3 equal to 0, because either this one or this one has to be 0 to make the statement true. And then of course I'm going to subtract 5 from both sides on the left side, and I'm going to add 3 to both sides on the right side. And those are my two solutions that make this particular statement true. So if I were to plug in either negative 5 for the y over here or a 3, it would make this entire statement true, and it would make it equal to 7. Just for fun, let's try that. I'm going to plug in 3 here. So 3 squared is a 9. Negative 2 times 3 is going to give us a negative 6. So now I have 9 minus 6, which gives us a 3. And hold on just a second. I made a mistake. A small one, but mistakes do happen. I'm trying to achieve a negative 2 here. If it's 5 minus 3, that's going to be a positive 2. So the 5 has to be negative, the 3 has to be positive. So the 5 is negative, the 3 is positive. So in this case, the 5 had to be negative and the 3 had to be positive. Again, make sure that makes sense. This is early in the morning for me, so my apologies. So if that's the case, there would be a negative here and a positive here. And when you solve this, you would add 5 to this side here, so that would make that 5 positive. That would make this 3 negative. Now let's see if that works, now that I corrected the mistake. If I plug in a negative 3 in here, negative 3 times negative 3, so negative 3 squared is a 9. Negative 2 times negative 3 is a positive 6. So 9 plus 6 is 15, and then 15 minus 8 gives us our 7. Now it makes sense. So this is why checking your work is actually very useful. Sometimes you will catch yourself making silly mistakes like I did right over there. Alright, so if you have any other questions, you are more than welcome to ask me when we go over this homework in class. Thank you very much.